All right, repeating decimal, take two. So this time I'm going to try and show the rationalization of the repeating decimal 0.275757575. So my understanding then would be to break this guy down. So just remember, this is the same as saying 0.275. Like I said earlier, 75, and it doesn't stop. It keeps going on forever like that. So I'm going to take the piece that's not repeating, and I'm going to chop that guy off because that's going to kind of get in the way. So it's like saying 0.2 plus 0.075. That way, if I add those, I get 0.275. And then if I add another decimal of that, then I get 0.00075. And what this will do is it'll allow me to get 0.2 plus that is 75, plus that is another 75, plus, and then I'll just do one more just to show it, 3, 4, 5, 7, 5. All right, and this is going to go on infinitely, right? So it's going to go on forever, and that's what the repeating decimal is. This guy is not part of the sequence, part of the geometric sequence that's infinite, and the reason, or series, sorry, and the reason it doesn't follow the repetition here, but this guy is. This part of it is. So we want to start off by establishing, well, what is this guy here? This guy is 75 over 1,000. 75 over 1,000. And then to get over here, I have to multiply it. This one is where it's a little bit different. 75 over 100,000. Is that right? Yeah. So essentially multiplying this by 100. So this is going to be 75 over 1 with 5 zeros. 1, 2, 3, 4, 5. Plus, and then this guy here is another one. 75 over, so from 5 zeros, it's now 7 zeros. Geez. 1, 2, 3, 4, 5, 6, 7. So 75 over 10 million, and it's going to keep doing this forever. Okay, so you're just going to keep getting more zeros in the denominator. And what we can start off by saying is that our A sub 1, our first term, is just 75 out of 1,000, 75 over 1,000. And then we can also say that our R, our common ratio, is 1 over 100 because we're multiplying each of the denominators by 100. They're increasing by 2 zeros. And since it's an infinite geometric series, we can say that the sum of this infinite geometric series is just A sub 1 over 1 minus R. All right, so then I'm going to simplify that, or I'm going to plug it in and solve it now. This is going to give me 75 over 1,000, 75 over 1,000 over 1 minus R. Sorry, the R, we actually know, the R is 1 over 100. Now in the last video, I multiplied the top and bottom by 1,000 just to get rid of the fractions. I wasn't a big fan of it. If you don't like that, you can just leave it like this and you can start simplifying it. You can say, well, 1 minus 100th is 99 hundredths, so then you can have 75 over 1,000, 75 over 1,000 over 99 over 100, and then you can simplify that guy right there. So those zeros will cancel out with that. So you have essentially 75 over 990. Now that right there is only, this right here only represents this. So that fraction, the 75 over 990, only gives me the repetition. What I need to do is make sure I include the 2/10. So what we're going to do is we're going to add 2/10 to that. It looks like we have to multiply by 99 to make a common denominator. So I'm going to multiply this guy by 99, and this is going to give me, 198. So 198 over 990, and I have to add that to the 75. So now I'm going to have my answer, I guess I can just throw it up here, is going to be 200, sorry for the lag on this because I gotta think about it, 273 over 990. Now if I don't believe that that's true, then what I want to do is plug in a calculator and just show that it's 0.275 where the 75 repeats. So we're going to go 273 divided by 990, and we get the 0.275757575, and it goes on forever, just like that.